Hey everyone! Have you ever looked in a mirror and wondered, how does that light know exactly how to come back to your eyes? That, my friends, is reflection, one of nature's simplest yet most magical light tricks. When light hits a shiny, smooth surface like a mirror, it doesn't just disappear, it bounces back into the same medium. This is what we call reflection of light. Every time you see your face in a mirror, sunlight of a lake, or even the gleam from a phone screen, you're seeing reflection in action. Light always travels in straight lines, and when it hits a surface, depending on how smooth or rough that surface is, it can reflect in different ways. Smooth surfaces give regular reflection, clear, sharp images. Rough ones cause diffused reflection, scattered light, no image, but still following the same rules. Alright, let's get serious, but not too serious. All reflections, whether on bathroom mirrors or shiny car paint, follow two very elegant laws. Law 1, the incident ray, reflected ray, and the normal all lie in the same plane. Think of them as teammates on one flat sheet of paper, they never jump off. Law 2, the angle of incidence equals the angle of reflection. Say it with me, I equals R. That's written as I equals R, where I is the angle between the incident ray and the normal, and R is the angle between the reflected ray and the normal. As you can see in the diagram, both rays make equal angles on either side of the normal, perfectly balanced, as all good laws should be. This equality holds for every surface, smooth or rough. Reflection never breaks the rules, it just looks different when the surface isn't flat. Now that we know how reflection behaves, let's see what kind of image a plane mirror actually forms. When light rays from an object hit a mirror and reflect back, your eyes trace them behind the mirror, and voila! You see a virtual image, erect, same-sized, but not real. Mathematically, the image distance is equal to the object distance. In simple terms, if you stand 1 meter away from the mirror, your image appears 1 meter behind it. It's like there's another you in a parallel world, same height, same look, but flipped left to right. Yes, lateral inversion makes your right hand look like your left in the mirror. And no, mirrors aren't lying, they're just being geometrically correct. Let's talk about what happens when light reflects off different kinds of surfaces. Imagine a smooth mirror. Every ray bounces off neatly and stays parallel to others. That's regular reflection, and it forms a clear image. Now picture a wall, rough, uneven, full of tiny bumps. The reflected rays scatter in all directions. That's diffused reflection, and no image is formed. Here's the cool part, both types obey the same laws of reflection. The difference is only in the surface texture. So technically, when you see sunlight bouncing off a painted wall, you're seeing physics in action, just a more chaotic version of it. This scattered reflection is the reason we can see everything around us, even objects that don't produce their own light. Let's quickly tie it all together. Reflection is simply the bouncing back of light into the same medium. It follows two elegant laws, I equals R, and all rays lie in one plane with the normal. Plane mirrors give virtual, erect, and same-sized images, while rough surfaces scatter light but still obey the same rules. From mirrors to periscopes, from car headlights to solar cookers, reflection is everywhere around you, quietly shaping the way you see the world. So next time you catch your reflection, give a little smile, you're literally seeing physics at work. Until next time, keep observing the light around you, because the universe is reflecting more than you think.